Hi everyone, welcome back to the channel. Today we are starting a brand new series, beginner friendly system design. Instead of dry theory, I will tell you a story. A story about a developer named Hamza Chaudhary. He is a $1 billion cat video app called CatTube. And all the problem he runs into as his app suddenly goes from tiny side project to internet scale jobs. So by the end of this video, you will understand what system design actually is, scaling, like the vertical versus horizontal, load balancer and their algorithms, TCP versus UDP, HTTP versus HTTPS, HTTP versions, CDN basics, cache, caching for the Redis, strategies, problems, database partition and sharding, and trade-offs in large distribution system. And all of this in simple conversational language with examples you will actually remember. So instead of drawing everything from sketch on camera, in recording, I will use a well organized diagram. You have already actually I have already prepared in this eraser.io. Okay, and this is a really a clean version. Okay, it's much cleaner and should make the CatTube architecture easier to understand at a glance. And you can see I already prepared everything for you. So let's dive in. This is our high level CatTube architecture. Actually, this is the whole scenario we will talking about in this series. In this video. So I also distribute this. Separate everything part by part here. So it will help you to understand. I already break down these things. So you understand the every aspect. Every topic or lessons when I go through this part. Okay, great. Okay, imagine you are Hamza Chowdhury. Okay, so you are a hardworking software engineer at a well-known company. One day, a $1 billion idea hits you. So you think I will get you a platform, okay, where people can upload and watch cute cat videos. You get hyped, open your laptop and start coding. You know how to build the front end, create API, design a database, deploy a server. So you grind for 2 months and finally launch your cat tube. And then boom, people love cat videos, right? Who knew? Who knew? Right? That's the whole thing. Thousands of users start signing up. Viewers are growing, uploading uploads their videos. Uploads are going, and likes and comments are also upgrade. It also boosting. At the office, you already. Remember, you are a Hamza. So you are already daydreaming about throwing your resignation letter at your boss's face. And the dream doesn't last very long. Suddenly, users start complaining. The app is super slow. Videos are not loading. Okay, my I mean my likes aren't showing up. Comments are disappear. Your logs are full of error. CPU and RAM are on fire. Server are crashing. You are panicking. So you run to your office guru or your colleague, senior colleague, or senior brother or your big brother. So he listens and smile and drop the bomb. You know how to write code. He's talking. You know how to write code, but you don't know system design. Without that, your app is guaranteed to collapse. That's where our journey really starts. Okay, so now the question is, what is system design? Really? So you also thinking, your first reaction is probably the same as your. Like just think, Hamza, his first reaction is almost, probably the same as yours. I know how to code. I know database. I know how to deploy to server. What is left to design? So here is the key idea. Right coding is like a laying bricks or line bricks. System design is like creating the blueprint for a building. If you open a tiny tea stall in the corner of your neighborhood, you don't need much planning. A small shed, a kettle, a few cups, you can manage it alone. A few customer, no big deal. But if you want to open 100 branches across the country, like KFC, serving millions of users, millions of people every day, you can't just wing it. You must think about building structure. What is the building structure is? So it doesn't collapse when 1,000 comes in. Kitchen layout. So food can be served fast, supply routes, how ingredient comes in and waste goes out, safety for emergency exist, fire safety, etc. Software is the same, exactly same. When CatTube had just a few user, a single server and a single database were enough. But when millions of users arrive, so the question comes up: how will you keep the app fast? How will you keep it always up? How will you handle spikes and failures? System design is the process of creating that overall blueprint: architecture, components, data flow, scalability plans, reliability strategies. In simple word, system design is the art of turning ordinary code into a massive, scalable, reliable system. So Hamza realized something important. He has been laying bricks for years, but he never designed the building. Now, the next section or the next topic comes up. Next question comes up: scaling. I mean, now how you can scale vertical versus horizontal. Now, this is our diagram. Remember what is happening here. In here, just you can see the load balancer, route, and your mobile client or browser, CDN. See, this part actually here also. Remember, those are this one actually your high level architecture, and this is your breakdown. Okay, so let's go back to CatTube. At first, you maybe or Hamza does this simplest thing. He takes a old dusty laptop. Just remember, okay, dusty laptop, installs the backend and database and uses it as a server. Remember, single laptop, single server. Just a few user. Okay, so he thinks, come on, who's going to use it at the start, right? Simply, this is totally beginner level. You just publish your application. So you also may be thinking that yeah, there's a few user. So what? Let's just use the simple, single laptop. Okay, he also thinking like that way. Then the app takes off. 100 users, laptop fan sound like a helicopter. CPU and RAM 100%. App crashing, laptop nearly die. So Hamza goes to a tech market, spends his saving and buys a monster PC with a huge RAM and CPU. So he moves CatTubes to this supercomputer or monster PC. Now 5 or even 1,000 users, no problem. Happy again. Then popularity explodes. More users, more uploads, more likes and comments. Even the new super machine starts to choke. Hamza finally realized no matter how powerful my single machine is, there will always be a limit. So he studies scaling. There are two main way to scale. Okay, so come here. I just take this one. Okay, great. So just think this is your note. Okay, this is the user. Okay, so we are talking about this is the topic. This topic number is just think this is our, just come here and let's say scaling vertical, maybe uh, okay, great. Scaling vertical versus horizontal. So there are two main way to scale. One is the vertical scale, another is the horizontal scale. Vertical scale is the scaling up, horizontal scale is scaling out. Okay, so let's break this down. First, the vertical scaling. Vertical scale means one machine. Just think this one. You have a one machine, more power. Maybe increase the RAM 4 to 32 or 64 or 120. Doesn't matter. Or upgrade the CPU. Use a faster disk like SSD or NVMe. This is what Hamza was doing. So what is the advantage if you are using a single monster PC? Simple to set up, simple to manage, only one server. So as you know, advantage, if you have advantage, so you also have a disadvantage. So then what is your disadvantage? Not your actually. What is the disadvantage of this vertical scaling? Hard limit. So what is hard limits? You can't upgrade forever. Hardware has a max capacity. Second point is expensive. High-end CPUs, RAM, and disk get exponentially costly actually. Disk get exponentially costly. The third, single point of failure. If this one machine dies or restarts, the whole app is down. Okay. The point is for vertical scaling. This is a this is the vertical scaling point. Okay. So let's think vertical scaling advantage and disadvantage. Okay. So vertical scaling is good in the beginning, but it can't take you to true internet scale. So our next topic is scaling. So copy this one, come here. So this is our scaling button. Okay, two and this is a one. Okay, great. So horizontal scaling. So horizontal scaling equal instead of one huge machine, you add multiple normal servers and share the load. Two server, five server, 10 server, even hundreds. Doesn't matter. Okay. So what is the advantage? Advantage is almost unlimited scaling. Just add more servers as load increases. Cost effective. Like 10 cheap machines are often better than one super expensive machine. Fault tolerance. If one server die, other can keep serving user. So disadvantage, more complex architecture, harder to manage. You know, you actually know must think about how to distribute traffic. The load balancing, how to keep data consistent, network latency between machines. Okay, so this one advantage and disadvantage. Okay, great. Next, so now you already know the vertical scaling, horizontal scaling. That means you already compare both. And now actually Hamza also think actually he also compares both and decides to make CatTube truly big, I need horizontal scaling. So he sets up multiple server, but now there is a new question. Okay, I just show the canvas now because now the actual thinking happening here. So the question is, if I have a 10 servers with 10 different IPs, which one will each user connect to? That leads to the next topic. Okay, so before moving to the next topic, I want to explain what is happening here. Okay, because you already watching this part, but I just explaining these two things. But what is happening here and what is the meaning of these things? So let me tell you shortly because I also explaining more here. So okay, no problem. But think this is a global users. Okay, all over the internet and request to your server. Just think. This global user actually sends request to your service. Those requests first hit this Cloudflare with the DNS and the CDN, which does two main things. It resolve your domain name to an IP. IP means the DNS, and can cache static. The caching asset library or provide security for CDN or WFM or etc. So after Cloudflare, traffic is directed to Amazon Route 53. As a example, I'm showing you the whole result from AWS services and also their icons. Okay, everything is AWS service. So Amazon Route 53, which is AWS DNS or routing service. It can route traffic to different AWS regions or endpoints based on rules. The latency based routing, health checks, etc. Finally, Route 53 send the request to an application load balancer, the actual hero here, the load balancer in AWS actually. Okay, the load balancer distributes incoming traffic across multiple backend servers, instance, containers. As an example, think the EC2, ECS, EKS. Those are also AWS services. So just think those things. Okay, the server. Just think the EC2. Okay, just think this one is the EC2. So no single server is overloaded and you can scale horizontally without any issue. Also, when you get the server. I mean, this server also send a request to AWS RDS. You can think this is a database. Okay, it send a request to your database and get the data from your database. And here, as an example, shown the PostgreSQL. I mean, the relational database. Okay, great. So in short terms, user, Cloudflare, Edge, AWS. I mean, Amazon Route 53. I mean the routing for DNS routing, and application load balancer. Okay, it split the request across your app server and it send the request to database. Okay, great. So let's talk about the load balancer, the traffic police. Just think this one is a traffic police. Now imagine a big company office. When you enter, you don't directly run into the CEO's room. Okay, you go to the reception desk first. The receptionist understand why you come and send you to the correct person. So exactly same thing. This load balancer actually play exactly that role in front of your servers. From the user perspective, all user only know one domain or one IP, maybe CatTube.com. They send all their requests to the single address, right? And that's the truth. We generally, and you can see, we I just typing this address, but behind the scene, it also running another system design. I mean, another free servers. Like I'm from the South Asia, so maybe you are from America or Europe. So those servers are totally changed. Okay, so behind the scene, you might actually have a 5, 10, or 100 server. The load balancer sites in front service all incoming traffic, and it decide which backend server should handle each request. Also, it then forward the server response back to the user. Okay, you just don't think it just sending the request and it stop. No, when it receive the data, I mean it received the actual response like 200 okay status code. That means it send the request to the user directly. Okay, and if you can see here, you will understand this is your user. You see the load balancer, it's testing, it's checking. You see server come here, and it's send yeah, this is another part. Just think this is the Amazon cloud front, and it send the request, and you can see it. I mean it's automatically understand, like you can see this send the server, and also it's come here, it's received it directly received from the cloud front. How it send a request to server, then it's take the videos, I mean your data from your AWS, I mean Amazon S3 bucket, I mean the video bucket, and then then send a request to CloudFront, and CloudFront then send the load balancer. Okay, I mean just think this is the process. Okay, after everything is finished, and it send the request to the user. Okay, great. Now come here. So one thing I think you already clear, the user doesn't know about all these backend server. They only see one entry point, the load balancer. This load balancer. Okay. So what rule does the load balancer use to decide which server to send the request? That's where the load balancing algorithm comes in. So the load balancer, I mean, now you think maybe you also learn. I just think okay, not we are not talking. We are talking about. I mean, we are talking about the story, right? So Hamza learns about a few common algorithms. Okay, now let's take a notes from here. Load balancer algorithm. So first algorithm name is round robin. Just think this is your Ludo style. I hope you also play the Ludo. Okay, this is the simplest. How it's simple? How much? Like request one to server one. Okay, that means just think from here. This one request one. I mean one user, one request. One request, it's directly sent to one server. Second request, it's sent to the second server. Okay, and then maybe 10, 100, 11. So back okay, if you have a 10 server, just think you have a 10 server, then when the 11th requester comes in, I mean 11th user, then it's directly back to server 1 again, because you have a 10 server. So when the 10 server and 11 number user will directly redirect to the first server in terms of count. Okay. Um, So advantage is very easy to implement, distributes request evenly. I mean the in terms of count. Okay, that I mean disadvantage. This one is the advantage, and also the disadvantage is dumb. Doesn't care whatever a server is currently busy or free. If some server are weaker, they might get overloaded. So that's the thing for the Robin round. Advantage, disadvantage. The next is weighted Robin round. I mean round robin. Sorry, not Robin round. I mean the round robin. More powerful, more work. Not this one. This one. Weighted robin. I mean round robin. More power, more work. That's interesting. But if one server is a super machine and another is just a old laptop, you can assign weights. Okay, like powerful server, weight will be 5. Weak server, weight will be 1. So out of every 6 requests, 5 go to the powerful one and 1 goes to the weaker one. This way, work is divided according to capacity. Okay, great. So this is the, I mean, this one is the actually advantage you can say. Another one, I mean, the third one, this one, two. The third is least connections, shortest bank queue. Imagine you enter a bank with 5 counters, you naturally go to the counter with the shortest queue. Least connection, actually, this least connections does the same. It tracks how many active connections each server currently has. A new request is sent to the server with the fewest active connections. Useful, I mean, the advantage is useful when some requests are long running, like video uploads. Others are short, like simple API calls. Okay? Okay. So number 4, IP hash. Just think famous, barbar or sticky sessions. Sometimes you want the same user to always go to the same server. Why? Maybe that server holds that user session or in memory data. In memory data. IP hash actually doing for you. I mean, actually his advantage is takes the user's IP, run a hash function, always maps that user to the same backend server, same server. Okay. So how it's relevant to here? Just think, if you are from America, then your server should be nearby you in America. Even though if you are from North America, then your server should be from the North America, not South America. Okay. And this is also known as a sticky session. Okay. Another one is other algorithms. Like this is I actually tell you the quick overview here. Uh, Maybe you can take the brief notes like least response time, least bandwidth, random, customs. Those also be algorithm. Okay, I just take it here for you guys. Okay, and just bolded it. Okay, so you can see the least response time, bandwidth, random, and custom. Those are also be algorithm. Like response time for the peak the server that currently responding fastest, and bandwidth peak the server that sending or receiving the list data right now, and random it's literally just pick a random server, and custom your own rules, totally up to you. So now come here. So Hamza initially thinks, okay, so it just forward traffic. Then he discovered load balancer are Swiss army knives. They can do a lot more, like auto scaling. Suppose a very popular cat influencer goes live on CatTube at midnight. Suddenly traffic explodes. I mean, you get I mean the spikes. Okay, and this is totally natural. Now Hamza can tell, or you can do. I mean, you can tell your load balancer. I mean, Hamza can tell the load balancer or cloud platform, as our reference is the AWS. This is a cloud platform. If average CPU usage on my server goes above 80%, you automatically start more servers. Okay, remember, you can see there is a 3 server. That means we set the limit. If it's above 80%, you automatically start more server first. And second, when load goes down, automatically shut down the extra server. Okay, isn't it auto scaling? This is called auto scaling. So health checks like sick server or leave. So machines crash. That means the process die. The load balancer periodically pings each server. Are you alive? If server responds 200, okay, that means the server is okay. Then the load balancer sending a request this server. If this server is not okay, not sending a request to load balancer 200 status code, then this the load balancer automatically shut down this server and it's stop to sending into request to this server. Okay, great. Now, if a server doesn't respond or return errors, the load balancer marks it as unhealthy. Okay, right? And stop sending traffic to it units until recovers. This is how we get fault tolerance. Now, zero downtime deployment. Think. So Hamza wants to deploy a new version of this of his backend. Without a load balancer, he might have a restart the server, causing downtime. With a load balancer, he can now get he can there is advantage. Update one server with new code, send a small percentage of traffic like 1% to that updated server. If everything works, gradually update and shift more traffic. Users never see downtime. That's the whole point because we all use the Facebook, Twitter, Instagram. Do you ever realize, ever down those things? Maybe you just scrolling your feed. Immediately you see it's refreshed and the UI is changed without any downtime. Now, load balancer not only scaling your server and also protect the also the zero downtime deployment, not this one also, they can also do security and DDoS protection like block suspicious IPs, throt- throttle throttle too many requests from one source, help observe the DDoS attacks when attacker flood your app with fake traffic. Next, there is a lot like SSL termination, the encrypting, the HTTPS and decrypting traffic is CPU heavy. Instead of burdening every backend server, you can terminate SSL at the load balancer, forward plain traffic to the internet server. This simplify the backend and the reduce CPU load here. Okay, that's why most of the time, maybe you notice already, if you are using the VPN and then with the fake ID, fake IP, sorry, you can notice that server automatically shown you to no, you are not allowed to visit this site. Okay, that means this IP are blacklisted. This simplifies the backend and reduces. That's why this simplifies the backend and reduces your CPU load. Okay, great. So back to our story. Now Hamza explored the market and finds there is a few types of load balancer. First, hardware load balancer. Another is the software load balancer. Third, cloud load balancer. Fourth, DNS load balancer. Okay, and finally, the layer 4 versus layer 7. Okay, layer 4 load balancer and the layer 7 load balancer. So Hamza explored the market and find this hardware load balancer, which is dedicated physical applications, super fast but very expensive, used by very large enterprise. So software load balancer, software like Nginx, it's called the hub proxy, running on regular server, flexible and cheaper. But you manage upgrades, scaling, etc. You can do that. But okay, those are the software load balancer do. Next is the cloud load balancer. This is the interesting, like provider by AWS as an example. I already show and tell you, like the Google cloud provider or Azure, Cloudflare, etc. No need to manage hardware, auto scaling, health checks, and features are built in. Perfect for startups and small teams. and this is actually too good. Believe me, this is too good. Next, for the DNS can return multiple IPs for the same domain. Like one user might get IP for server A, uh, user 2 might get the server B. Cheap and simple but dumb. DNS doesn't know if a server is down. DNS result are cached, so changes propagates slowly. So the next type is layer 4 versus layer 7. So layer 4 load balancer, you can think this is a transport layer. I mean the TCP or UDP. Okay. So TCP means actually transmission control protocol, a core part of the internet protocol suite that ensure reliable, ordered, and error check delivery of data between application over IP network. And the UDP, UDP means user datagram protocol, is a fast connectionless transport protocol user for time sensitive application like video streaming, online gaming, and DNS lookups. Okay. Well, TCP is slower but reliable, ensuring order and error checked delivery. Okay. So the layer 4 load balancer, the transport layer, work with IP plus port only. Doesn't look inside the HTTP request. Very fast but not smart. So the layer 7 load balancer application layer, actually this is the application layer like the HTTP, can see URLs, headers, cookies, can route, for example, slash video slash I mean IDs, whatever, I mean the video server, or the slash APIs slash something API related ID or something. That's mean the backend API server. More powerful, but uses more resource. For CatTube, Hamza choose cloud load balancer layer 7. So he can make smarter routing decision. Okay, so that's why this is happening. We are using the load balancer here, and in this diagram you will see the as a load balancer we are using the AWS cloud platform. Okay, and for latency, I mean for also you can see we are using the Amazon Route 53 for low latency. Great. Okay, just for now I already mentioned the TCP UDP. Now I explain it more about this topic. I mean this TCP UDP or HTTP or HTTPS, it's all the networking basics. Okay, so let's time for networking. Hamza open AWS console, tries to configure his load balancer and sees protocol HTTP, HTTPS, TCP, UDP. Now he freezes. What is this? What even is TCP versus UDP? I just want to show some videos. So he goes back to his colleague or his brother, I mean the big brother. So now the question comes up, what is protocol? Okay, a protocol is just a agreed upon language and grammar for communication between computers. If you go to Japan and start yelling in, like my language is Bengali, no one will understand. You both need to speak the same language. Similarly, two computers must follow the same protocol to communicate correctly. As an example, just think the TCP or UDP rules for how data travel over the network. HTTP and HTTPS rules for how browser and web servers talk. As like SMTP and IMAP for email. I think we are familiar. I mean, we are familiar with this SMTP server for sending email, right? As like same things. So you could invent your own. I mean, own means the Hamza protocol, but the standard was already exist and are battle tested. Let's look at the TCP versus UDP. Okay, these all are the theoretical part, so that's why I didn't sketch any diagram here, because these things are directly connected to your network. Just try to understand how it's managing. As I mentioned, when you are selecting, I mean in your AWS console and choosing the load balancer, I mean configure your load balancer, then you need to select those networking protocol. Okay, so just try to understand what is it. It will be helpful for you. So first, TCP, the reliable gentle mode. Think of sending a registered letter. You want confirmation that the letter reach your friend. You care about reliability and order. That's TCP, the transmission control protocol. The key features: connections oriented actually. Before sending data, TCP uses a three-way handshake. First, client to server, then server to client, and finally client to server. Just think as a story like very fast, client means user. I mean, just think the client. This is a user who actually sending a request, and sending to request to the server. So just talking to two person. One, can we talk? This is the first part. I mean, three-way handshaking. Remember, the first question is, can we talk? Then the other person responds, yes, I'm here, ready. Then the other person, I mean, the first person actually reply, great, let's start it. That means client, server, server, client, client, server. Okay, that's the things. So these things is important. So let's come here and here text paste this. This is the things. Okay, this is the process for, I mean, the how the TCP uses a three-way handshake. Actually, just remove from here because we are noted those things here, right? So pasted it here. Three-way connection protocol. Okay, that's the things, and this is the key feature. And just copy. Okay, maybe okay. So good. Okay, now it's related to this part. Okay, and we are talking about this is the topic for TCP. So let's connect it this here. Okay. Okay, great. Now, for the reliable delivery, if a packet gets lost, TCP detect it and ask to reset. Ensure all data eventually arrives. So order data. I mean, remember this one is the first topic. Okay, just remember this is your first topic, and these all are the. I mean, this one is the key feature. Okay, this is a key feature. Remember, just come here. This is a key feature. Okay. Second one is reliable delivery. Reliable delivery. Third one is order data. Okay. If you send packet 1, 2, 3 or more, the receiver will see them in that order. Okay. So final one is the that means the final one is the congestion control. If the network is congested or slow, TCP itself slow down sending. Helps avoid network like the traffic jams. So used for web browsing like HTTP 101, I mean 1.1, HTTP 2 use TCP. Emails, file transfer. In short, TCP is polite, careful, and safe, but a bit slower because it does a lot of checks. So the next one is, I mean, this one is the TCP. So the next topic is the UDP, the fast but careless guy. So now imagine you are doing mm, miking in the market with a loudspeaker. You don't track who heard it, who didn't. You just shout and move on. That's UDP, user datagram protocol. So the key feature, actually, the key feature is connectionless, unreliable, and very fast and lightweight. Okay. So connectionless means, so that's the key feature. The connectionless, unreliable, very fast. This one kind of the no handshake, just send data. Unreliable means doesn't guarantee delivery, order or returns, and very fast and lightweight, less overhead, smaller headers. So when it used, low latency is more important than perfect accuracy. A few lost packets don't matter much. So for the example, when using this UDP, like an example, video calls, online gaming, live streaming, or DNS. That's why that in that time need to use the UDP because when are when the user in call or like live streaming, it doesn't matter which one are watching you or not, right? You just need to show your actual purpose. You are serving your purpose. If user are interested, they stay. Otherwise, they just go. So in this case, a small glitch is better than a 2-second freeze. Okay, great. So this is the TCP and UDP. Next is the HTTP versus HTTPS. I mean postcard versus scaled envelope. The next question Hamza asks is, big brother, we always type HTTP or HTTPS in the browser. What's the difference? Think of it HTTP as sending an open the postcard. Whatever you write can be read by the postman, anyone along the way, anyone who intercepts it. If you send your password or credit card over pure HTTP, it goes in plain text. If a hacker if a hacker side somewhere between you and the server, like a man in the middle attack, they can just read your request. But HTTPS fixes this problem. HTTPS means HTTP plus encryptions, means TLS or SSL, SSL certificate. Okay, that's why we are using most complex the SSL. I mean HTTPS. Okay, great. Now it's like putting your letter in a strong envelope, locking it with a key. Only the server has the machining key to decode it. I mean, sorry, only server has the matching key to decode it. Even if someone steals the the packet, all they see in gibberish. So today, browsers warn you loudly if a site uses plain HTTP for login. Sometime maybe you notice when you try to visit any site without HTTPS, it's immediately block you and tell you this site is harmful. Don't go there. Okay, and almost all serious websites use HTTPS. So for CatTube, HTTPS is mandatory if users are logged in or sending any sensitive data. Now, the version, HTTP versions from 0.9 to 3. HTTP has a version like 1.0, 1.1, 2, 3, 3 point something. Why so many? A quick history. HTTP, the HTTP 0.9, remember, a very early, super simple, only supported the GET and only HTML. No header, no status code. One request, one response, done. Okay. Then comes with the HTTP 1.0 version. Now added a headers, status codes, content type, but each resource need a new TCP connection. If your page had one HTML plus 10 images, it open a new TCP connection for every single one. Big overhead, very slow. So then comes in 1.1. This because the default way for many years. Key improvement here: persistent connections like keep alive, reuse the same TCP connection for multiple requests, don't open or close repeatedly. Host header, this host header actually the same IP can now host multiple websites. For example, cattube.com or Hamza AI or something.com on the same server. Okay, better caching, chunked response, etc. But it still had a problem called head of line. HOL blocking. Head of line. Requests are sent seriously. One slow response can block others behind it. That's the another key point. Then comes the HTTP 2. So to fix that, HTTP 2 introduce multiplexing. The multiple requests and response over one connection, broken into frames that are interval. No more waiting behind slow resource. Binary format. This binary format faster parsing for machine. Header compression, like the reduce overhead. Server push. The server can push resources it knows the client will need massive. Client actually will need those things. So that's why it push massive speed improvement over HTTP 1.1 in HTTP 2. The major version of the HTTP 2. But it's still a deep problem. It is still set on top of TCP. That means the TCP has head of line blocking at the packet level. Then the HTTP 3, the QUIC, quick. So Google and others did something bold, build a new transport protocol on top of UDP. It's called Quick, QUIC. Then build HTTP 3 on top of Quick. Benefit: fast connection setup, true multiplexing, built-in encryptions. I mean the TLC 1.3 version. Today, many large platforms like YouTube are already using HTTP 3. For CatTube, when you become a huge, HTTP 3 will matter a lot for global users. Okay, great. So this is the part just the, in that time we are talking about this only for load balancer, and in this load balancer you already notice the network is involved here. So the that much of speaking actually is relevant to this load balancer. I hope you understand this. Next is the CDN. This CDN now explain. I mean explore this part. Okay. I mean this CDN part actually this one is another one because this CDN are connected with the video. Okay, just for now you will understand here what is happening. I mean CDN means content delivery network. Okay, CatTube now uses multiple server as a load balancer, uses the HTTPS, maybe even HTTP version 2. Still, now complaints start coming. User close to the server are happy, but user in other regions say videos are buffering forever. It's so slow for abroad. As I mentioned before you see, user is Asia. Maybe you are from Europe or America. So I uploaded this video from this server and it's only run from this Asian server. That means you are facing difficulties. Video are buffering forever. It's so slow from abroad. Okay. Now, some the things. Let me just add more server. Maybe he does. Maybe you do. Bills go up. Whenever you include a server, that means you are paying per hour for this server. Remember, performance doesn't improve much. So he again back to his senior brother. So he explained now, he actually explained the CDN, I mean the content delivery network. So what is CDN? I already explained it shortly. So suppose your origin server is in the USA. A user like from the Southeast Asia or South Asia or whatever from Asia want to watch a video, request travel, I mean the travels from, just think, user from Asia, he sent the request. Just forget about this part now. He sent the request directly from Asia to USA. Video comes back USA to your country or your region, I mean the Asia. That distance adds latency and buffering. Now imagine you open a small warehouse in whatever, maybe in New York or in from Asia, maybe in China in Shanghai, or from my country, just think in Dhaka. You keep copies of popular videos there. Now the Dhaka user doesn't have to go to the USA. They get the video from the nearby warehouse. This network of many geographic warehouse is a CDN. I mean, this warehouse means the CDN server. The components, I mean, the key components here, the origin server, your main server, the actually the factory, and the edge server is the CDN nodes all around the world close to user. So CDN stores copies, I mean the cache of static content like images, videos, HTML, CSS, or JSON. When user requests a video, CDN choose to edge server closest to them. If that edge server already has the video, I mean it's already hit this cache, it serve directly. If not, I mean the cache means it fetches from origin server to the user and store a copy for future. Then what is the benefit? Speed, less distance, lower latency, reduce load on origin. Many requests never reach your own server. Lower bandwidth cost at origin. Maybe you already noticed. If you are using any social networking app, I mean Facebook or Twitter or YouTube, you see it's immediately start. I mean without any buffering because of this. CDN, and for this cache. Okay. Now next part is the pull versus push CDN. The pull CDN, the most common today. At first, CDN has nothing. When the first user request, just think. Initially, when user send a request, you will understand from here. Maybe, uh, maybe this one. Wait, just think. Initially, user send a request. Okay, it's something similar. This one. Okay, not exactly same thing, but this one will tell you the. I mean, you will understand if the server, I mean the user, just think, user send a request. Okay, this is another thing. Just think, user send a request. This is your cache server, but initially, very first time when user send a request, it's actually means the server because there is no cache available. That it's directly go to your database or AWS. I mean, like if you are uploading a video or watching a video, this is your origin, video origin. The AWS S3 buckets. Okay, Amazon S3 bucket for your video origin. So what it does do, like Cloudflare DNS, this is our DNS server, right? And this is for the networking. This thing. Okay, it send the request to Amazon CloudFront, then it's immediately send SW, I mean sorry, S3 bucket, and it's take the video from this origin, I mean the video origin, and send this CloudFront, and this CloudFront actually send this app. Okay, so initially very first time cache will be not available, so it's directly hit the server, origin server. A server doesn't have it, right? It pull from origin and cache it. Next users get it from this cache because the first user already hit it, and this one is already caches first. I mean cache it because it's already used. So there is one downside. First user has to wait a bit longer. First request penalty. Just think this one is the first request penalty. So upside is you don't manage anything. CDN automatically caches what becomes popular. Next is push CDN. You push file from your own site to all CDN nodes ahead of ahead of times. I mean the ahead of times. Okay. When users ask, everything is already in place. So what is the upside? Even the fast user gets super fast response. Downside, higher complexity. You must manage uploads, updates individually. In most web apps, full CDN is enough and ideal. For huge static bundles like game installers, push can be useful. Okay. The now the final benefit for the CDN, and the benefit, if I recap, that's it. Latency down, faster user experience, origin bandwidth down, like lower cost, handle viral spikes. I mean, millions of users hitting the same video. CDN edges handle most of the load. Okay, for you without any hassle, without any buffer. Security, many CDNs provide built-in DDoS protection and WAF, means the web application firewall. So CatTube becomes blazing fast worldwide now for a while. Okay, for a while. Because the problem never finished. It's always comes with the new problem. Now, our next topic, I mean the topic number 7, caching database bottleneck. I mean the caching and database bottleneck. After CDN, videos load fast. Now, this is the example we need to explain, and I will show you here. The caching and database bottleneck. After CDN, videos load fast, no problem. But a new ghost appears. User report, videos load fast, but my comments don't show up. Likes are not updating correctly. Profile page are very slow. So Hamza checks the database server. It's shown CPU near 100%. Disk maxed up. I mean totally mixed out. I mean maxed. Disk level is already maxed. The problem now is the database, and this is your database. And read and write are killing it. So Big Brother is, I mean Hamza's Big Brother introduced another key concept. It's called caching. Now the question is, what is caching? Previously, just earlier, we already learned the caching part, like for videos. Those are handled by the CDN. But now the problem was coming from our database. Okay, that means this is a backend caching. I mean backend issue. Previously, it was the video issue, video serial issue. Now the problem comes from our database backend issue. Okay, so what is caching? Think of a huge library. The library shelves are like your database on disk. Your small disk is like memory or RAM. If you keep going back to this shelf for the same book over and over, it's a waste of time. So what do? You bring the book you are actively using to your desk. You keep it nearby for fast access. Caching does exactly the same in software. The main database store everything on disk. Just think this is your main database. It store everything safe and persistent. A separate caching layer like the Redis or other things. I mean the mem cache, maybe think mem cache, Redis or mem cache, but Redis is popular. It stores hot data in memory. Okay, why? RAM is much faster than disk. Reads from cache are order of magnitude. Magnitude, I mean the magnitude faster than reads from database. Okay, and you already see app server. It's send the request to user, but you can think like here. Just think there is a user. Just forget about this part for now. User send a request to CDN. CDN request to the load balancer. Okay, and this load balancer again sending to the server, and server actually send, I mean the server take the data from Redis cache. If data is missing initially, it's sent, I mean sending the data to database, and database send the data to this Redis first time. If the cache is already stored, then when server send a request, it's not sending the request to the database, it's directly send this data from this cache, and server will send the data to the user. But RAM is expensive and limited, so you don't cache everything. You cache the most frequently used or most performance critical data. For CatTube, example, metadata of trending videos, like counts, frequently viewed user profile, popular comments, threads. Now the question is how caching helps. Right now, for a single viral video, every user view triggers many DB reads, video title, description, thumbnail, current like count, list of comments. If millions of users do this, the DB dies under read load alerts. With caching, the frequently read value are stored in Redis, I mean in the RAM. Application read from Redis instead of database. As I already mentioned that it's read directly from Redis instead of this database. For the benefit of the result is latency drop, RAM is ultra fast, DB load drop, don't every request are sending to the database. That means database can breathe. User experience improves, fewer timeouts, faster pages. Okay, now read through versus read aside cache. How does cache actually get data? Two popular pattern. First is the read cache. Okay, I mean sorry, read thought through. I mean the read through. Your app only talks to the cache. As you can see, you are only talking to your cache. Cache actually talking to the database when he needs. When app asks for data, if cache has it, then cache hit, return immediately. If not, I mean the cache miss, then it's sent. I mean cache itself fetch from database, store it, and then returns. Okay, your app doesn't, I mean does not know about the database cache handling. Okay, now the next is read aside. I mean the cache aside, most common. Your app is responsible for both cache and database. For the flow, app looks in cache. If cache hit, return the data. If miss, app queries from database. Okay, there is a two option. App return data and write it into cache for future. Most people use this pattern with Redis or Memcache because it's flexible and simple. Then when cache is full, eviction, like yeah, I mean the when cache is full, just think as the eviction policies. What happens if cache memory is full? Think of your fridge. When there is no space, you know out. All leftover. Stuff no one eats anymore. Cache do the same thing. Common strategies. Uh, List recently used LRU. List recently used that remove data that hasn't been accessed for the longest time. Great default for most apps. And second topic is, I'm sorry, second strategy is the LFU. So I listed this here. It will be helpful for you. Okay, those are the common strategy. LRU, least recently used. LFU, least frequently used. FIFO, I mean fast in, fast out, and another is the random. Okay, so for the LFU, frequently used, remove data that is rarely used. Okay, and the FIFO, it means remove the oldest inserted item. For random, just randomly evact something. CatTube would typically use the first one, LRU, recently used. So only fresh, not data, I mean, sorry, hot data remain in Redis. Okay, so only fresh. So the cache invalidation, I mean, keeping data fresh. You might be thinking, if I cache data and then someone update it, how does the cache know? For example, you cache a video title, creator edit the title, or DB is updated, but cache might still show the old title. This problem is called cache invalidation. It's famous for being hard. There are a few patterns. Okay, like more caching gotcha, you can say. You can think, I mean, the thundering head, I mean, the thundering heart. A viral video's metadata is cache. Suddenly is TTL expired at time T. The next, I mean, the thousands of requests all miss to cache at the same moment. All of them hit to the database. DB gets hammered. Okay, from here. So mitigations is stagger expiration times. Proactively refresh hotkey before they expire. Use small random jitter on TTLs. So the big key is putting a giant object, like an example, 10,000 comments in one entry into Redis, like consume memory, takes time to serialize or deserialize, can block the cache server. So the mitigations is split large structure into a smaller chunk, paginate or cache summaries instead of full blobs. So cache pollution. Okay, next part is the cache pollution. I mean, next study is cache pollution. Cache ends up storing data that almost nobody reads. Real hot data has no space left. So the good, I mean, actual advantage is good eviction policies like LRU or LFU. Careful what you decide to cache. For the cache penetration, many request query non-existing IDs by bug or attack. Cache can't help because nothing is stored for that key. Every request goes straight to DB and wastes resources. So navigating caching, store, I mean, this key doesn't exist for a short time. Validate IDs before hitting database. Okay. So once I mean the Hamza, where Redis is properly with a good strategies, CatTube's database finally breathe again. Read are fast, write are manageable, time to celebrate, but not yet, because there is a new problem is comes in. The problem is data partitioning and sharding. This one, okay, data partitioning and sharding. Some month pass. I mean, just think, this application now is faster than before. Already solved lots of issues already, because we already handle lots of things. Now the problem comes in the partition, data partition and sharding. Serial handle video delivery, cache handle hot reads, load balancer and multiple app server handle traffic. But the new pattern appears right. I mean the writes the upload new comments likes are getting slower. Certain tables are becoming huge. Even simple inserts are slow because indexes are massive. The core issue is one single database instance is doing all the writes and holding all the data. So Hamza return again. Hamza return to his big brother again. This time the topic is data partitioning, so called sharding. That's why you can see there is a multiple database now here. Database 1, 2, 3. It's called sharding. Data partition. Now the question is, what is data partition? Think of your main database are actually your one giant elephant. At same point, it's too big to move, too slow to backup, too heavy to handle every request. For ideal, sorry, instead of one giant DB, split data into multiple smaller pieces and split them across multiple servers. So for the definitions, partitioning. Okay. So one single server, now it's partition. You can see it's, yeah, there is a directory. In this directory, there is a partition. Or you can see app server shared route. Okay. This is good. Too good. So logically, splitting a big table or data set into a parts. That's why I'm showing here the directory. The folder. Here, just think it's a big table that are splitting logically or data set into a parts with these three parts. The user shard 1, 2, 3. So this shard a physical partition, one piece of data on a specific server. For the benefit, each shard has less data, so query are faster. Load is distributed across multiple machines. Easier to scale. You can add more shards, servers as you go. You can see there is a multiple. If you want, you can you can partition this one and as much as you want as a servers. So you when you it's go, and that's why here you see this is your main server, and now it's partitioning it to another server. This is your cache server. Even though we use the multiple, sorry, this is not server. My bad. This is a data. The Postgres sequence database. There is a multiple database, and this is the server we use for user, like right. And for that we using the load balancer, and in here we just partitioning our actual database. Now another topic is comes horizontal versus vertical partitioning. Two way to cut a table. Vertical partitioning, cut by columns. Take the videos table. It might have 100 columns, title, thumbnail, description, state, analytics, etc. But the home page might only need ID, title, thumbnail, duration, uploader. Just these 5 fields. Vertical partitioning is split into 2 or more tables by columns, like videos underscore basic. The frequently used is small, or video details heavy in frequency field, or joined by video ID. Okay. For the benefit, queries that only need basic info touch a small narrow table. Less IO, the faster reads, better cache usage. Now, horizontal partitioning or sharding. It's called sharding when you partition cut by row. So let's note it. The horizontal or vertical partitioning. So this thing is the vertical partition. Okay. Another one is the horizontal partition. Okay, great. Horizontal partitioning or sharding. Cut by row. This one is cut by column. Okay, the two main partitioning types. So in horizontal partitioning, all columns stay the same, but row are split across server. Example: user ID, a user with ID is 1 to 100K on shard is this one. The shard one. Okay, come here. This one. Okay, shard one. Okay, and 100K to 200K will be shard 2 maybe, and then more, then it will be stored in shard 3. Okay, or all video uploads maybe in 2024 on one shard, and 2025 videos on another shard, another one, and this year, I mean the 2026 will be another partition based on year. This is what we usually refer to as a sharding. Hybrid system often combine both vertical and horizontal partition. Okay, so here is the sharding strategy, and this sharding strategy is important. Now the key question: how do we decide which shard a piece of data belongs to? Exactly same things are happening when we thought for how this server will be communicate. So we use the load balancer. So in here, in common strategy like range based sharding, come here, range based sharding. Yeah, I mean use a range of field like ID or date. Like example, I mean as I mentioned, the shard A, shard B. So the pro is simple to understand, good for time based data. Example, logs by month or year. So for the cons, risk of hotspot, the latest range get all new write and traffic can overload a single shard, maybe. Okay. So second strategy is hash based sharding. Okay. This is our second. So the sharding strategy, second strategy will be the hash based sharding. Just think, take a key as a user ID, run it through a hash function, map hash result to a shard. So then what is the benefit? Spread data evenly across shards, great for avoiding hotspots. Then what is the disadvantage? Harder, I mean the cons are harder to move data if you change number of shards. Knife hashing breaks when you add remove shards like fix with consistent hashing, but that's a deeper topic. Just for now, understand this is one. Another one is geographic sharding, like partition by region or location. Asian user store in Asian database cluster, US user store in US database cluster. Okay, so what is the pros? Low latency for user, data is physically closer, helps with data residency rules, like an example country regulations. Then what is the cons? User who move region or global features like global search become a trickier. Okay, another strategy is directory based sharding, like maintain a separate lookup table directory that's a user 123 shard 5 or user 5 I mean 456 in the shard 2. Okay, app first queries this directory to find the right shard, maybe like for this directory sharding. Okay, I can show you this actual flow, it will be great, this one. Okay, so the pro is very flexible. You can move user between shards by just uploading the directory. So the cons is directory itself must be highly available and consistent. Becomes a critical dependency. Okay. Okay. Next sharding is dynamic automatic sharding. And another one, hybrid sharding. Okay. Just think, dynamic sharding is the system automatically split and merge shard based on size or load. Common in managed cloud database. Okay. As like the server. If value 80%, server automatically shut down. Okay. If not, I mean sorry, if value 80%, it's the server is automatically up, like when the spike, I mean viewer. Okay, that's like this one, and cloud actually follow this path. So what is the pros? Less manual work, more elasticity. Okay, so cons, much more complex under the hood. So the next is hybrid sharding. Real world large system usually mix geographic plus hash, vertical plus horizontal, etc. For example, first separate by region. Within each region has on user ID. This gives both low latency and balanced load. So what is the pros and cons of partitioning? Benefit is performance, scalability, parallelism, blast reduce. I mean failure in one shard only affect subset of user. So the drawback is operational complexity, cross shard queries, data skew or hotspot, migration pain. Okay, still at large scale partition is unavoidable. To grow CatTube, Hamza must accept this trade-off. Then this trade-off, the cap trade-off are comes in. The reality of trade-offs like cap, parcel, teaser. So after the load balancer, CDNs, caches, sharding, CatTube finally feels like a true distribution system. A distributed system. But Hamza noticed something subtle. When he tries to keep all copies of data perfectly in sync, performance suffers. When he optimizes for speed and availability, data sometimes becomes temporarily inconsistent. So he called his big brother again and asked, "Isn't there a perfect design where I get maximum speed, same data everywhere, 100% uptime, all at once?" Then his brother, his brother laughs and say, "Welcome to the real world of distributed system. Here, everything is about trade-offs. No system can give you everything at once." So the next we will talk about the cap theorem and the parcel theorem. After that, you will understand why perfect is impossible. And that's where we will push this video. In this episode, we cover what system design really means, scaling for vertical versus horizontal, load balancer and algorithms, TCP versus UDP, HTTP versus HTTPS, HTTP version, CDNs, and how they speed up content caching with the strategies, invalidation problems, data partition, and sharding. So we already covered this all the things here. This topic we already covered. Okay, I hope you already understand. Now as a beginner, you will understand which one you actually choose and why you are choosing this thing, and also the versioning, why those version are coming and what they serve when the version the major version are coming. Okay, right. So in this, okay, I have a plan for, the in the next video of this beginner friendly system design series. Maybe we will continue with Hamza Chaudhary's story and dive into maybe the cap theorem. The consistency, availability, partition, tolerance, maybe the parcel. The PACELC, the latency versus consistency trade-offs, and how real system choose what to sacrifice. Those three things. Okay, in next video maybe I will cover those things, or more point, more example. Maybe it will be great for you to understand. But here you can see the consistency. It's check the availability and then go to the partition, your cloud, the partition tolerance, and then the partition actually sending the request to the consistency. So this is the trade-offs view. Okay, I hope you learn something, and this is totally beginner friendly. Most of the things are theoretical because this system design all about the concept, consistency. How actually you can think this is totally design based concept. Where is the problem and how to fix those things? Where those everything are coming for solving the problems. Okay, the actual architecture is this one, and this architecture tell you why we need those things and what is the benefit if we follow those architecture. Okay, so that's called the high level CatTube architecture. So hopefully all the best for you. Try to recap the full video again. Rewatch the videos. If you face any difficulties, comment below your thought. I'm always available to reply your comments. Bye bye.